What are 3D objects, and how are they made? Hi there, welcome to SelfCAD. If you're watching this video, you may find yourself in one of these situations. You're completely new to 3D modeling. You have graphic design experience, but you're new to 3D modeling. Or you've just started learning 3D modeling, but you don't understand how it works yet. If any of those sound like you, then you're in the right place. In this video, we'll cover the very basics of 3D modeling. If you're already familiar with 3D modeling terms, and if you understand what makes an object 3D, we encourage you to head on to part 2, where we'll be covering how to position 3D objects. Here's an overview of what we'll be covering. First is, what makes an object 3D? Secondly, we'll discuss some key 3D modeling terms that you need to know. Area, volume, 3D surfaces. To further illustrate what makes an object 3D, we'll also discuss some graphic design terms like pixel and point cloud. Lastly, we will introduce the concept of area and volume and how they are used in design software. Let's begin. We live in a 3D world, which means you can reference the coordinate position of any object relative to your environment. For example, a GPS gives its 3D coordinates position relative to the entire world, but you can also use a local coordinate system to indicate its position relative to a room, etc. However, the fact that you can use a 3D coordinate system to reference an object's position does not make that object 3D. So what makes an object 3D? A three-dimensional shape is defined as a solid object that has 3 dimensions: length, width, and height. Unlike two-dimensional shapes, three-dimensional shapes have thickness or depth. So for example, we have a square. If you add thickness and depth to it, it becomes a cube. Now, let's take it a step further. Since you'll be working with CAD software, you need to understand the distinction between physical and digital 3D objects. So, how does digital design differ from physical 3D objects? All physical objects that we can see and touch are by definition three-dimensional, because they must have some thickness or else you would not be able to see and touch them. But that's not the case with digital objects. 2D objects that we see on screen are unique because they don't have any thickness. Hence, that cannot exist in the real world. However, that does not mean you can't measure them in 3D, because measurement is related to the environment rather than the object itself. Let's illustrate that with a line. If you draw a line and measure it relative to a 2D plane, you'll only get 2 axes as notated by an XY coordinate system. However, once you introduce a 3D workspace, you can now measure the same line relative to 3 axes as notated by an XYZ coordinate system. How are digital non-3D objects created? The fact is that any big object is made of smaller pieces. That is true for physical objects and for digital objects alike. However, the relationship between the smaller parts and how they connect to each other make a big difference. And they define the type of object, how they are made, and how they behave. Typical images, also known as raster images, are not more than a set of pixels put together in one compressed file that we call an image. They have no relationship to each other, hence you will need to fill in each pixel. Or else, it will leave empty gaps, and similarly, editing a single or set of pixels will have no impact on the remaining pixels. How are 3D objects made? Digital 3D objects are made by combining a set of polygons in a way to create a bigger shape called a mesh. Much like you can add a relationship to 2 points and extend them into a line. You can the same way add a relationship between connecting polygons, also called faces, to make a 3D mesh. When you connect faces but without creating a closed shape, you will have a surface, and when closing them, you will get a solid. A closed 3D solid is also called a watertight mesh, And a watertight mesh can be a 2D object with added thickness or hollow 3D shapes as long as they have thickness. This also means that every watertight mesh must have a volume. Hence, 3D surfaces are not considered watertight. What about closed shapes? Closed shapes such as a rectangle, circle, or any custom drawing stay 2D, as long as they do not have thickness. Since you can always measure the entire area relative to a 2D environment. However, once you add thickness, the object itself becomes 3D, because you need 3 dimensions in order to measure the entire volume, regardless of its display environment. Now, let's go over important terms that you need to understand when learning how to see, think, and design in 3D. Area versus volume. Area is the amount of space occupied by a 2-dimensional flat object, while volume is defined as the space occupied by a 3-dimensional object. Physical objects always have a volume. Hence, they are 3D, but digital objects can have an area without a thickness, which means they are 2D, but once you add thickness, they get a volume and become 3D. 3D surfaces. We've established that 3D objects require depth and thickness, but there's a special case for 3D surfaces. Curved surfaces are rather unique, because you need a 3D environment to display them, and you need 3 axes to notate its coordinate positions. But they do not occupy any 3D space as they have no volume. This means that 3D objects can exist without having any thickness or depth. But they are not considered a solid geometry. If you add thickness, it will get a volume and be considered a solid geometry. Pixels versus point cloud. Pixels are 2D objects, but you have a similar concept in 3D, which is called a point cloud. A point cloud is like a set of cylinder balls placed in a single box without any relationship to each other. You can still move all cylinders at once in the same way that you can move a box of balls, and when it comes to digital objects, you are not limited to moving. You can also scale, as well as perform many other transformations, because you work on the entire box as a whole. Still, the fact that there's no relationship between each small part means you have to fill in each part individually, and editing some have no impact on others, as with the case of pixels. Now that we've covered some key terms, let's discuss the relationship of vector graphics and 3D CAD software. If you have some background knowledge in graphic design, this might be exciting, and well, if you don't, it's still something that we will encourage all 3D learners to understand. Vector graphics and 3D CAD software. When it comes to vector graphics, you are still working with smaller parts, but they have the ability to add relationships between parts. For example, a line is made of just 2 parts, and the relationship creates the connecting line. This means that the same 2 points can be used regardless of the size of the line, which is why vector graphics are great for scaling, because you do not need to fill in each pixel, hence they do not pixelate when scaling. Vector graphics become even more powerful when connecting lines in a way that they close a shape, which you can at that point already fill in the entire area without adding any additional pixels or points. A closed 2D shape is also called a polygon, and you need a minimum of 3 lines, also called edges, in order to close a polygon, but you have no maximum, and you can create very complex shapes that will automatically fill the inside, as long as you have a closed shape. 3D CAD is similar to 2D vector graphics. They just extend the same concept into a 3-dimensional environment, and they allow creating 3-dimensional objects and 3D solids that can automatically fill all closed shapes. Now, let's go over what it means to work with the concepts we just learned. First, we'll go through working with an area. Next is working with volume. And lastly, working with object details. These concepts are important in understanding how digital 3D objects behave in a CAD workspace like SelfCAD. Working with an area. The concept of area. plays an important role in vector graphic design software. You can overlap multiple areas and create new shapes based on the combination, subtraction, or intersection of the objects. These operations are known as Boolean operations. 2D Boolean operations are well known and used in 2D design software such as Adobe Illustrator, but you can also do the same in SelfCAD's freehand drawing tools. Working with a volume. Boolean operations play an even bigger role in 3D modeling software. SelfCAD's stitch and scoop tools allow you to intersect multiple objects as a way to join, subtract, and intersect them. Many CAD software call them Boolean tools, while SelfCAD calls it stitch and scoop, as a more friendly user name that suggests what this tool is actually doing. Boolean-based modeling is a very powerful tool and is widely used in many different industries. However, they have some limitations, since all the objects need to be watertight, also known as manifolds. They are also very time-consuming when making organic and complex shapes. Some software, such as Tinkercad, relies solely on Boolean-based modeling, and they only have union and subtracting options, which is why it gets complicated to accomplish even simple things such as making beveled edges, etc. SelfCAD Stitch and Scoop, on the other hand, also has an intersection option, which is a very powerful method for creating parametric designs and for creating wrap text on objects, etc. Working with the object details. When it comes to making more complex designs, you would rather want to work directly with the components that make up the object. This type of modeling is called polygon-based modeling, and this is what makes SelfCAD so special. SelfCAD has the most user-friendly interface. It is relatively easy to learn, and it's super easy to use, as compared to any other polygon modeling applications. SelfCAD enables you to deform the object components with ease, and has the ability to edit the actual structure of any object, also known as the object's topology structure. Conclusion. We hope this video gave you a better understanding about digital 3D objects. As a next step, please watch the video titled How to Position 3D Objects to learn more about how to navigate CAD software. Thanks for watching, and make sure you subscribe to our channel for more 3D modeling content.